As you've already seen, dealing with trig expressions and trig identities is going to involve some of your algebra skills. This video is just going to very quickly go through some tricks you might have to use. So I'm going to use some terms you might hear and going to show you some things that you need to be aware of that will help you solve identities and simplify expressions, okay? One, we've already done this. We can separate fractions. If you have a sum or a difference, had to be a plus or a minus, over a denominator, you can split this up into the split up numerator all over, or each over the denominator. So in this case, 1 over sine theta would be cosecant theta. Sine theta over sine theta is 1, and we get cosecant theta minus 1. Okay? The next one, multiplying binomial conjugates. Conjugates means I have a binomial, that's two terms. One of them's minus, one of them's plus. They match exactly. One minus sine theta, one plus sine theta. The two terms are the same. The sign in the middle is different. So one minus, one plus, with the sine theta on the other side. Those are called conjugates. This is going to be what you may recognize from algebra. You may have learned FOIL, first, outer, inner, last, same thing. But something happens when the binomials are exactly the same, but one of them's a plus and one of them's a minus. So we do 1 times 1, we get 1. 1 times sine theta is plus sine theta. Minus sine theta times 1 is minus sine theta. And then minus sine theta times sine theta, we get minus sine squared theta, okay? Now what happens is those middle terms, since one of them's a plus and one of them's a minus, they cancel, they become 0, and you're left with 1 minus sine squared theta. If you got real good at multiplying and doing FOIL, you may skip this step and go straight down here. What's important to remember when they're conjugates, when they're exactly the same, except for the plus and minus, those middle terms cancel, and you're left with the first term squared minus the second term squared. Okay, this next one is going to do the sort of the opposite of what we just did. We're going to start with what is called a difference of squares, and we're going to factor that into two binomial conjugates. You may recognize this if you remember factoring. If you are factoring a difference of squares, that will factor into a minus b times a plus b. That's how a difference of squares factor. If you were to re-multiply here, just like we did it a second ago, it'd be a squared. The outer term and the inner term would cancel, minus b squared. So what I have here is I have a difference of squares. So that factors into cosecant theta minus cotangent theta times cosecant theta plus cotangent theta. Since that is a difference of squares, it will factor that way. Then I'm going to put that over. I have a hard time writing cosecant for some reason. That. And then I look and I see, well, that and that are the same thing. So they cancel, right? Cancel, cancel. And I'm left with cosecant theta plus cotangent theta. I could put that into reciprocal functions, but that's not really going to help things any. This is my simplified term. Now, this next one is multiplying something by its conjugate. This is a nifty little trick. If you dealt with imaginary numbers and complex numbers, you may have seen this. If you have a binomial and whatever its sign is, you can multiply by the conjugate, which means to do the exact same thing but change the sign. And of course you have to do that over itself, right? Because in order to not change the value, if we multiply by something over itself, we're just multiplying by 1, right? So we're not changing the value, we're just changing what it looks like. So we're going to multiply that top. 1 times 1 is 1. I'm going to go over here since this is off center here. Plus cosine theta minus cosine theta goes away. That's the reason we did that. And then minus times a positive would be negative. That would be negative cosine squared theta. When you multiply by the conjugate, the middle term goes away and you end up with this difference of squares. And then on the bottom, the denominator, we have sine theta times 1 plus cosine theta, okay? Now, you might recognize up here 1 minus cosine squared theta. That's one of our manipulations of the Pythagorean identity. If we know that sine squared plus cosine squared is 1, then sine squared is 1 minus cosine squared, okay? So that'll be another one you'll want to be familiar with. So that top expression is really just sine squared theta over sine theta times 1 plus cosine theta. Now, if I have something squared over itself, one of those is going to cancel, and I'm going to be left with just sine theta on top, because this is sine theta times sine theta, right? Sine theta times sine theta on the bottom, one of them is going to cancel. And I'm left with sine theta over 1 plus cosine theta. And that's really all we can do with that. You cannot split up a denominator like we split up a numerator, so we're done. All right, this last one is also something that you did when you learned algebra. It'll look maybe a little different when you're dealing with trig, but you can factor a -1 from, this says from a binomial. It could be from any expression. But if I look at this top and I want to factor a -1, I'm going to take a -1 to the outside, and when I factor out a -1, I change all my signs. So this would be negative cosine squared theta and plus 1. Okay, so think about distributive property. If I were to distribute this -1, the negative times a negative would be a positive. The negative times a positive would be a negative. So I took this -1 out, and that changed all the signs. I've still got the sine theta on bottom. Now, the reason I did that is because now I'm going to take this and I'm going to write it, I'm going to reverse these two. I'm just going to write negative on the outside. I'm not going to write the -1. It is -1, but I'm just going to write negative. And I'm going to write that as 1 minus cosine squared theta. All I did was change the spots. I put the +1 in front and the minus cosine squared at the back. Over sine theta. Well, we just talked just a second ago that 1 minus cosine squared theta is sine squared theta. So this is minus sine squared theta over sine theta, okay? And sine squared over sine, one of those signs is going to cancel, right? I didn't show this a second ago, but this is sine theta times sine theta over sine theta. One of those cancels, and I'm left with minus sine theta. When you take that minus out, when you factor that negative, don't lose it. It's got to be in your final answer, okay? Unless something else happens to it along the way. So basically what happens here, look what happens between here and here. When you factor out, and it was a subtraction, when you factor out that -1, it reverses. So, for example, if I have, let's use numbers as an example. If I have 3 minus 2, that is the opposite of 2 minus 3, right? 3 minus 2 is 1, and then 2 minus 3 is -1, and the opposite of -1 is 1. So when you factor out a negative, you can do this little flipperoo on a subtraction problem, and sometimes, like it was here, it becomes a little easier to deal with, or a form that might be a little more helpful. All right, if you have any questions, note them. We'll be talking about these algebraic manipulations as we go along. They show up in different places. If it's something you're not remembering, ask me. I'll be glad to help you.